Hello everyone, in this video we're going to talk about how we can graph some radical functions. And in this video we're going to talk specifically about square root functions and cube root functions. So it says a radical function contains a radical expression with the independent variable, that would be x, in the radicand, which is under the radical. So the square root of x, cube root of x, something like that. When the radical is a square root, the function is called a square root function. And when the radical is a cube root, the function is called a cube root function, okay? So let's get started off by talking about two very important functions for each of these two families, and that's called the parent function. So the parent function is super important because all other functions are transformations of this parent function. So if we can memorize and know what the parent function looks like, then we can kind of figure out what has happened to a transformed function because of the differences between the one we're looking at and what the parent function looks like. So let's start on the left side of the screen. Let's talk about the square root function of f of x equals the square root of x. So this would be our parent function. So if we take some good values, so some perfect square values for x, you know, when we say when x is 1 or when x is 4, because we can take the square root of those numbers. So we see right here that we have a point at 1, 1, and we have a point at 4, 2. Because the square root of 1 would be 1 and the square root of 4 would be 2. And so that's the general shape of our square root function. If you notice, it's kind of like just half of a sideways parabola. And that essentially is the case because it's the inverse of a quadratic function, but we have to restrict the domain or else it would not be a function, right? Because if we had this other part of the parabola down here, well, now it doesn't pass the vertical line test, so it's not a function, okay? So when we're talking about square root, our domain, our x values are just greater than or equal to 0. Our graph's going to go to the right. And our range is also greater than or equal to 0. So we're going to go up. We're going to be basically just in quadrant 1. All right, now for cube root, we have f of x equals the cube root of x would be our parent function. And notice this one is a little more of a curve as we see. So if we think about three easy values here, so the cube root of 1 is 1, the cube root of 0 is 0, and also the cube root of negative 1 is negative 1. So we have those 3 points. And if we zoom in, we see that as our graph gets closer to the origin, it gets a little bit closer and it kind of just runs right down that y-axis just a little bit. Okay, so that's kind of the general shape that we want to know for our cube root parent function. And the domain and the range here, a little bit easier, it's just all real numbers, right? Domain's left and right, so we're gonna go left and right forever. And it goes a little bit up as it goes to the right and a little bit down as we go to the left. So what we're gonna do is look at two examples where we graph a square root function where there's been a transformation that has happened, and also a cube root function once we have transformed it as well. So number one, we have f of x equals the square root of 1/4 x. So the first thing I'm going to do is start off by plotting my parent function so that we can see how the graph is being transformed. So from the previous example, we know we have 0, 0. This is my x-axis down here. We're going by 2s. So 1, 1 would actually be right here. And 4, 2 would be right here. Okay. So we're kind of like zoomed in a little bit, so the shape of our graph looks a little bit different. Okay, but something like this, okay? Also, we could, since we have the room on this graph, maybe to make the shape of our graph look a little bit better, we know that of our parent function, the square root of 16 would be 4, so 16, 4, right? So we can kind of undo that shape a little bit to make it look a little bit better, right? So it'd be more like this, okay? All right, so that would be our parent function. So I'm going to write next to this just the square root of x, okay? And we'll switch up our color to green, and now we'll graph the f of x function of the square root of 1/4 x. So if you've had any past experience with transformations, with hopefully you have at this point, you notice that we are multiplying 1/4 to x. So anytime there's multiplication involved, that's a stretch or a shrink of the graph. And when we are multiplying x, it's a horizontal stretch or shrink. Because we are multiplying x and x, x values, x-axis goes left to right, so that'd be a horizontal movement. Now with horizontal, anytime we see horizontal stretch or shrink or a translation, it's kind of opposite of what it looks like. We see a 1/4 here, we might think, okay, that might be a shrink, right? Because it's a smaller number, less than 1, but actually it's opposite of that because we horizontally stretch or shrink by a factor of 1 over a, and here a is 1/4, so 1 over 1/4 would actually be 4. So it's a horizontal stretch by a factor of 4. So what we're going to do is we're going to take these 3 points, and really probably just the first 2, and we're going to multiply its x value by 4, right? And that's going to horizontally stretch us away from the y-axis here. So my origin point is going to stay there because 0 times 4 is still 0. But now instead of having a point at 1, 1, we're going to have a point at 4, 1, right? We stretched it from 1 to 4. Instead of having a point at 4, 2, we're going to have a point at 16, 2, right? So we stretched that. Instead of x value 4, 4 times 4 gets us to 16, right? And so as you can see, our x value of 16, we're not going to have enough room to graph that 16 times 4. So we're going to stick with these points, these 3 points right here. So we're going to draw our curve, and it's going to look just like that. So now this one would be the square root of 1/4 x, okay? So as you can see, we kind of like stretched it away, right? Horizontally stretched it away from that x-axis, or excuse me, the y-axis. All right, so our domain should not change here. Still x is greater than or equal to 0. Same for the range. Y is greater than or equal to 0 because we're still in that first quadrant, okay? All right, number 2, we have g of x is equal to -2 times the cube root of x. So with this one, we have 2 transformations that are happening. We have a reflection, and we also have a vertical stretch, and we'll talk about those, okay? So let's go back to purple and let's graph our parent function. So if you remember from our parent function, for cubic functions, our cube root functions, we have 0, 0, we have 1, 1, we have 1, -1. And remember, as we get closer to the center, right, this piece, like we're going like up really close to the y-axis, kind of hugging the y-axis till we get down here, and we're going like that, okay? So now from here, we can kind of just continue our graph like this, right that, okay? So now this would be the cube root of x, right? We haven't done anything to this yet. All right, so now let's go to green. And we're actually going to do 2 separate graphs here. So let's actually do red first, because green, we finished, our final graph was green for the first one, so we'll finish our graph. The final graph will be green on number 2. So let's go with a red color here. This will not be our final graph, but it will be one step towards our final graph. So I see this 2 right here, okay? And now this is telling me to vertically stretch my graph by a factor of 2. Vertical because we're not multiplying directly to x there, right? That 2 is outside of our radical, so that's a vertical stretch. Okay, so now we're going to multiply the y-coordinates of these points by 2. So this point right here is going to move up to 2. This point down here is going to move down to -2, but my origin point is going to stay in the same place. Okay, so now we can draw sort of our same shape here, and like this. Okay, so now this one would be just 2 times the cube root of x, right? So that's why we did it in red, because we're not completely done yet. We don't have that negative in there. Now we have this negative, right? We're going to be reflecting over the x-axis because we are making y opposite, essentially. That negative sign is not inside with the x. If it were, it would be a y-axis reflection. So this is an x-axis reflection. So I'm going to take my point that was at 1, 2, and it's going to move down to 1, -2. -1, -2 will move to -1, +2, but my origin point is still there. So as we can see, we've kind of just flipped this graph over the x-axis, right? And so now we can add these pieces to our graph just like this, okay? So the green graph that we see right here would be our final graph, which is our g of x function, -2 times the cube root of x, and that's what we would want it to look like, okay? So now, domain and range for this one, still all real numbers for the domain because we are going left forever and right forever, and range, once again, all real numbers, okay? So that's how you can graph some radical functions.